the shear force and bending moment diagram for this cantilever beam. So this is a cantilever beam. Now for cantilever beam, there is a choice for choosing the orientation. How to choose the orientation to draw the bending moment and shear force diagram? This is a cantilever beam with uniformly distributed load W. So there are two options. What are those? That is, one is shown in here. Once again showing to you. That is, we can choose the beam like this. That is, this is X. That is at fixed end. This is the fixed end. At fixed end, X equal to 0. And loading is same. That is uniformly distributed load. So this is one option. Another option is, that is, we take this orientation. That is, this is the fixed support and X equal to 0 at free end. Free end and X equal to L at the fixed support. So which option we have to take? If we choose option 1, say this is option 1 and this is option 2. If we choose option 1 and start to determine shear force and bending moment diagram at X equal to 0, there will be support reactions. One is R, that is vertical support reaction. Another one is support bending moment. So two unknowns we have to calculate first if we choose option 1. Whereas if we choose option 2, at free end there is no reaction forces. So this option, that is option 2, is free to determine these two unknown reaction forces. So our task will be easier if we choose this option for cantilever beam. So we will select this orientation of the beam as shown in the figure. As shown in this figure, we will not consider that fixed support is at X equal to 0. We will choose that free end at X equal to 0. Then we need not to determine the unknown reaction forces. So our next objective is to determine the shear force and bending moment for this cantilever beam of length L. Cantilever beam of length L, which is subjected to an uniformly distributed load of intensity small w. And this is the ordinate coordinate system. This is X, this is Y, and length is L. As there is no discontinuity in force, that is a uniformly distributed load, one section is sufficient to draw the shear force and bending moment diagram. So what we will do, we will take a section, say this beam is AB, we will take a section at C at distance X, at any distance X. So what will be the free body diagram? What will be the free body diagram? The free body diagram is like this. So this is my free body diagram. Load intensity is W. The at C, this is C, this is A. Shear force is Vx and bending moment is Mx. Shear force is Vx and bending moment is Mx. Now what is the resultant load due to W, small w? The resultant load will be this one. What is the resultant load? Resultant load is W into X. This is W into X, and that will act at distance X by 2 from A and C. So what is Vx? Vx plus Wx is 0. That is Vx is minus Wx. This is one expression by force balance. Now if we take summation of moment about point C is 0, that is summation of moments about C is 0, what we will get? That is mx plus Wx into x by 2 is 0. That is mx will get minus Wx square by 2, minus Wx square by 2. So we got both the expressions for Vx and mx. So Vx and mx now. So let me draw the beam first. So this is the cantilever beam and this is the loading. And Vx is minus Wx and mx is minus Wx square by 2, and this is x and this was y. Now let us draw the shear force and bending moment diagram. If this is x and this is shear force diagram, then shear force at x equal to 0 is 0 and x equal to L, the length of the beam is L, so x equal to L, that becomes minus WL, and this is a straight line, so minus WL. So this is the shear force diagram. Now let us draw the bending moment diagram. Now for bending moment, this is bending moment. At x equal to 0, mx is 0, and at x equal to L, that is WL square by L, but WL square by 2, but this is the equation of parabola. This is the equation of parabola and this is a straight line. This was straight line and we have already drawn the shear force diagram. Now the parabola will be like this. Sorry. So minus WL square by 2. Minus WL square by 2. So this is bending moment diagram and this was shear force diagram. So we have drawn both shear force and bending moment diagram for this cantilever beam.